Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very interesting homemade problem equation with complex numbers. Why do I call this homemade? Because I kind of came up with the idea, but anyone can do it, hopefully, and start making up some problems so you can present them or share with us in the comment section down below so that we can do them on these channels. So this channel focuses on complex numbers. If you're new to complex numbers, go ahead and check my lecture videos. If you like number theory and algebra, math in general, go ahead and check out my other channel, Cyber Math, Cyber with an S. All right, great. So we have this equation. How do we solve it? It's kind of like crazy type of equation, and I'll tell you after the solutions how I came up with this problem. So you're going to be in on a secret, okay? So stick around till the end because I will be presenting two methods. I'm not necessarily saying that both methods are going to be successful, but I'll give it a try, okay? Sometimes I don't even know if it's going to work. But my first method is basically going to focus on, and you know what, I can even think about three different solutions, but let's go ahead and try this. Replace Z with A plus BI, because why not, right? And from here, absolute value, which is also called the modulus, is going to be the square root of A squared plus B squared. Great, because we're going to square it, get rid of the radical. Nice. So let's go ahead and put the Z at the bottom or the base, and Z squared, absolute value of Z squared, by the way, is just going to be A squared plus B squared. Now here's a $1 million question. Are these two the same thing? I want you to think about it and answer in the comment section, okay? So, but absolute value of Z squared is just going to be A squared plus B squared, and that'll give us 2i. So here's the challenging part. I have no idea about A and B. I have two unknowns, and I have single equation. Can I solve it? Maybe. I don't know. We'll try. We'll explore some options. And I have something called an exponential, a complex exponential. How do you express Z to the power W? Easy. E to the power W ln Z. That's how you express it using Euler's form. And that's important because we can express 2i in the same format. Good. Let's do it on the left-hand side. What is the ln of a complex number? We'll talk about that next. But let's go ahead and use this. This can be turned into e to the power w, that will be the exponent, this, which is this, multiplied by ln of a plus bi. And that is equal to 2i. Now let's go ahead and convert 2i to polar form. Remember, 2i is right here, 2 units away from 0 on the imaginary axis, right? Because it's imaginary. So it makes an angle of pi over 2 degrees. So we can kind of write it as e to the power I pi over 2, but that would just be 1 pi. You do need 2 pi. So multiply by 2. Easy, right? Now, let's go ahead and see how we can solve this type of equation. Of course, natural log, right? You get rid of all the exponents, I mean the bases. This is going to turn into, hopefully, something nicer. And that'll be ln 2 because it is a number, not a power of e. Great. How do you solve this? Well, you need to think about the log of a complex number. What is it? Well, let me tell you that. Log of a complex number z is ln of the absolute value of z plus I times the argument of z. What's the argument of z? If tangent theta, if this is called theta, and tangent theta is b over a, theta can sometimes be found by arctangent b over a. I say sometimes because you have to check the quadrant. Well, let's just assume everything is nice and working. So now we can replace ln a plus bi by the following. ln absolute value of z, which is this, plus I times theta, which is this. So you like that? Super complicated equation with too many variables. But one thing that's really nice about it is you can distribute, right? A squared plus b squared multiplied by ln square root of a squared plus b squared plus I times a squared plus b squared times arctangent b over a. And that is equal to ln 2 plus I pi over 2. Nice. Now, here's a couple options. First of all, notice that we can compare real parts to real parts, which is nice. So this kind of gives us a squared plus b squared ln square root of a squared plus b squared equals ln 2. Let's start with that because that seems a little simpler, I think. And then we can incorporate the second one. From here, I can basically make this a power, right? And put it over here like ln this to the power that. And then I probably need to call this something. How about this? I call this r. Oops. I call this r. So this becomes r squared. Makes sense? So I have ln r to the r squared equals ln 2, which means r to the r squared equals 2. Nice. So how do you solve this equation? There's a couple different ways to go about it. Let me show you. First, I'll square both sides. That'll give me 4. And then this will become r to the power 2r squared equals 4. And then I'll put this 2 inside as an exponent and write this as r squared to the power r squared equals 2 to the 2. And from here, tada, one-to-one comparison or correspondence, r squared equals 2. That gives me two solutions, root 2 and negative root 2. But guess what? Modulus cannot be negative. Too bad. We have to go with this, right? Because r is the modulus. Remember, that's the length. Can be 0, but not negative. So we get r. That's good news. So we can kind of go ahead and plug it in. Because r is 2, or was it square root of 2? Yeah. If r is square root of 2, then this will be r squared, which is 4. And now I get another equation. Let me do it here. 4 arctangent b over a is pi over 2. Interesting. So from here, did I get that right? Hopefully. I don't know. Maybe I didn't. But something seems weird here. From here, we can get arctangent b over a is pi over 8. And from here, we can get tangent pi over 8 is b over a. Since you know r, you know a squared plus b squared, hopefully you can solve a system of equations. But guess what? I still have to show you the second method, and we'll hopefully finish that one. Because something got stuck with the first method. I don't know what it is, but I kind of got stuck. Hopefully you can help me out. Okay, so we have z to the power absolute value of z squared equals 2i. I hope I don't forget to tell you how I came up with this. But anyways, okay, so why don't we just use the polar form directly, like replace z with r e to the I theta. Notice this is going to be nice and much more compact. Of course, from here, absolute value z equals r. Absolute value of z squared will be r squared. So we get the following. R e to the I theta to the power r squared equals 2i. Let's go ahead and do it. It's r to the r squared times e to the power I theta r squared equals 2i. You see what I'm talking about? Now, this r to the r squared thing is coming up again, but in a much, much nicer way. I definitely like the second method, but it's up to you. You let me know which one you like better. So what do we do? Maybe I could use polar form on the right-hand side. Write this as e to the power I times pi over 2. That gave me a clue, right? Now we can say this following. Because these are both complex numbers like exponentials, why don't we compare these? This equals this and this equals that. So r to the r squared equals 2 again. And remember, this meant r equals root 2. We already talked about it. And the second one means I theta r squared equals pi over 2. I cancels out. R is root 2, so this is 2. From here, I get 2 theta equals pi over 2. I probably made a mistake with the first method because I was getting pi over 8. Come on. It's supposed to be pi over 4. So what was I looking for? For the z. Z is r e to the I theta, which is root 2 times e to the power I pi over 4. You can leave it like that, or if you want, you can write this as cosine pi over 4 plus I sine pi over 4, and then plug in the values to find the standard form for z, which is root 2 times 1 over root 2 plus 1 over root 2 I. If you distribute, root 2 is going to cancel out. You're going to end up with 1 plus I. Let me tell you how I came up with the problem. You probably figured it out, but here's how I did. I started with the solution or the answer. So I'm like, okay, what if I start with 1 plus I, find its absolute value, it's a radical. I don't want to raise this to a radical power. I want to raise it to an integer power so I can simplify. And I know that 1 plus I squared is 2I. So here we go. And this brings us to the end of this video and this problem. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to watch Cybermath, and bye-bye.